Hi, I'm Mike Yeaton, and this is my submission for the final assignment for the Machine Learning Foundations course. For this assignment, we're trying to predict the electrical output of a power generation system in megawatts per hour using 4 input features. We have 9,568 observations to work with. Step 1 is to determine what type of machine learning approach is needed and select an appropriate output metric. For the algorithm, I decided to use multiple linear regression because it's a very good model to try for a benchmark at first. It's very easy to interpret. It's easy to execute in Excel. However, it does assume a linear relationship between features and targets. So if we're not able to produce a good model using this, we may have to move on to other approaches such as neural networks. For the output metric, I will use mean absolute error, which is the absolute value of the differences between the predictions and the actual values divided by the number of observations. Average error is thus expressed as a term, hourly output in megawatts, that the clients will understand. I considered using mean absolute percent error, but this will make the errors seem smaller based on the high baseline values of the target, which are all over 420. Step 2, determine which possible features we want to use in the model and identify the different algorithms we might consider. As I mentioned, I'm leaning towards using multiple linear regression, but there are some options there. I looked at both simple multiple linear regression, but also lasso or ridge regression. Both lasso and ridge are helpful in reducing the tendency of linear regression models to overfit the data. But with only 4 input features, I think I can easily see this using multiple linear regression. Therefore, I'm going to try multiple linear regression with a few different combinations of the input features and see what produces the best result. Step 3, split your data to create a test set to evaluate the performance of your final model. What I did was I randomly sorted the data according to a random column, and then I split the data 85% to 15% between a training and test data. This produced 8134 observations for training and 1434 observations for test. I then used a fixed validation approach with the training data, meaning the different combinations of features I tried, I did on the same set of the 8134 observations. Step 4, use your validation approach to compare at least 2 different models. I compared 4 different sets of features using multiple linear regression, which produced the following output. First, I started with all 4 of the features as my input feature set. This produced a mean absolute error of 3.61 megawatts per hour. And since this seemed to me a pretty good result, it's less than 1% of the overall output of the system. Also, I can see up here that I had a 0.96 correlation between the predicted values and the actual values from the observations. So I'm pretty confident that this looks like something that would satisfy the client. But my next question is, do we need all these features? So I did the run again, the multiple linear regression again, but this time focused on a subset of the features. First, I looked at the combination of ambient temperature pressure plus relative humidity. However, in this case, the mean absolute error more than doubled up to 10.95 megawatts per hour. So it seems that these features are not highly predictive or as highly predictive of the target. I picked the other 2 features to see what they would produce. In this case, ambient temperature plus exhaust vacuum. And this produced a mean absolute error of 3.89 megawatts per hour, much closer to the number I got when looking at all the features. Finally, I decided to look at just the temperature alone to see what a big role this would play. And in this case, I saw the mean absolute error was 4.24 megawatt per hour. Again, not higher, but not dramatically higher than what we saw when we used all 4 of the features, input features. But given the assignment was to pick the best model for step 5, I then said I will use all the features to do my final performance evaluation using the test data. The best performing model, again, was the one where we used all the features in the training. So running that same model with all the features against the test data produced a mean absolute error of 3.71 megawatts per hour, which again, well below 1% of the output of the system and a very intelligible output metric for the client to understand. Thank you very much.